My name's Todd.
My name's Bob.
My name's Frank.
And my name's Sally.
And this is the Math Minute.
This week on the Math Minute, we'll be reviewing factored form, and I'll be focusing on chart method and tiles with a special guest from the Helping Hand. This is the Helping Hand here, introducing us to chart method and tiles. Starting off with chart method, in order to use chart method to its fullest extent, the coefficient on the x squared must not be able to factor into the other two numbers. From there, we take the equation and use Bergman technique, so we must multiply to 4, add to 5, and then from there, find two numbers that both multiply and add to those two. From there, we make a chart, as so, and in the middle, we insert the a value, which is 4x squared, and below the 1x and 4x, and then the 1 right there. And then from here we must find what can be divided into both numbers, which in this case is an x, so therefore we have 4x and 1, and x and 1. And these two numbers must multiply to equal that. So when factored, we have y equals 4x plus 1, bracket x plus 1. And that's our factored equation. In tiles, we will take the equation y equals x squared plus 2x plus 1 to show you. Alright, so first you must start off by drawing a big square to represent the x squared, followed by two long and thin x's to represent the middle value, which in this case is 2, so 1 and 2, followed by our last value of 1, and then draw a little cube to represent the 1. And from this, we can see the factored equation is y equals bracket x plus 1 bracket x plus 1.
Next, I'll be focusing on Bergman technique. We're back with Bergman technique, where man comes from multiplies to, adds to, and then two numbers that make up the above. Here we have a standard form equation, a, b, and c. We need to figure out what multiplies to a times c, in our case it's x times negative 33 equals negative 33, and adds to b, in our case is 8. And through process of elimination, we found that those two numbers are 11 and negative 3. So we bring our factors and put them into our factored form equation. From there, we make each factor equal 0 to find the zeros. X plus 11 equals 0, so we subtract 11 from both sides. X equals negative 11. And over here we have x minus 3 equals 0, so we add 3 to both sides to get x equals 3. So our two zeros are negative 11 dash 0 and 3 dash 0. And that's Bergman technique.
And after Bob, I will be focusing on perfect squares. We're back with the Helping Hand showing perfect squares. To find out if your factored form equation is a perfect square, you have to look at the two factors. The factors are the two sets of brackets. If the two factors are the same, then this will be a perfect square. So to find if your standard form equation is a perfect square, you have your equation here, so the square root of a times the square root of c times 2 equals b. b is the middle number right there in the middle. So the standard form equation is y equals ax squared plus bx plus c. All you have to do is sub it in. So here's an example equation, y equals x squared plus 6x plus 9. So if we sub it in, the square root of 1 times the square root of 9 times 2 equals b. So 1 times 3 times 2 equals b, so 6 equals b. Since 6 equals b and it's the same as the middle number on this equation, it will be a perfect square.
And finally, I'll be telling you all about the parts of a parabola. Next, we're going to be talking about parabolas. For our parabola, the equation is y equals negative x plus 2, x negative 6. The step pattern in our case is negative 1, negative 3, negative 5. You go over and down. If the parabola opens up, the step pattern is positive. And if the parabola opens down, step pattern is negative. Here's the y-axis, and here's the x-axis. For the y-axis, it's vertical, and for the x-axis, it's horizontal. A good rhyme to remember is y to the sky. The zeros are located here, and for our parabola, the zeros are negative 2, 0, and 6, 0. The axis of symmetry is located right here down the middle. And to find the axis of symmetry, you add the zeros and divide by 2. The vertex located here is 2.58. The 8, which is the optimal value, is the y-coordinate. And the 2.5 is the x-coordinate, and it's the axis of symmetry. That's all the time we have for Math Minute. We'll see you next week when we talk about vertex form.